Math is a wonderful thing. Math is a really cool thing. So get off your ass, let's do some math. Math, 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 math.
Okay, Algebra 2. Today we're going to be multiplying and dividing rational expressions. Okay, we're just going to start off with some basic ones. If you can multiply and divide fractions, then you can multiply and divide rational expressions. It's the same rules apply. The only thing that maybe we need to add into this is the fact that, remember, we have a specific domain when it comes to rational expressions. Remember, we can never divide by zero. Ever, ever, ever. Okay, so for our very first problem, I actually have two questions for you. Okay, it's going to be the same problem, okay, but just a little bit, different questions that are going to be asked of you. Okay, so our very first question is the expression defined at 0? Defined at x is equal to 0. So what that means is if you plug x into this, is it defined or is it undefined? That's all. It's a yes or no question. So where's x? X is right here and x is right here. It doesn't matter what goes on top, okay? But I have 0 cubed, that's 0. I can do that in the calculator, okay? And then this whole first fraction ends up being 0 over 5, and that's okay. That's 0, right? That's allowed. But this other half, this becomes 2 over 3 times 0. 3 times 0 is 0. That's undefined, my friends. We cannot do that, all right? So, our very first problem, or our very first question here, it asked us, is the expression defined at x is equal to 0? And our answer is no, it most definitely is not. Okay, so no. Okay, now the next part, I want us to multiply and cancel. Okay, so I want to actually multiply this out. Okay, so what we're going to do, I like to cancel and reduce as much as I possibly can before I do anything. Okay, so you can almost write this as one giant fraction, like 6 times x cubed times 2, all divided by 5 times 3x. We don't care what 5 times 3 is. Okay, I don't want that. I want to cancel stuff out. So, well, what can cancel? 6 over 3 cancels to 2 and 1, right? And then x's, where there are more x's, the top or the bottom. Then this is an invisible 1 right here. So there's 3 on top and 1 on the bottom. Okay, so that means there are 2 more on the top. So what I'm going to do is kind of just rewrite everything out and clean it up. So 2 times 2 is 4. And then I have an x squared. And then what's in my denominator? Everything's canceled out except for the 5. So this is my answer right here. All right, our next problem. Okay, I just want us to multiply this out first. So go ahead and pause the video and try to do it on your own and see if we get the same thing. So I'm going to do what I did before. I'm not really going to multiply anything out. I'm just going to break stuff up so that maybe it's a little bit easier to simplify. Okay. You could have 16 on the top if that helps you, and then 240 on the bottom if that helps you. It might not. Actually, you know what I'm going to do? Don't do that. I just made that 1,000 times more complicated. Let's just reduce these fractions first. 8 over 10. They're both divisible by 2, right? So that's 4 over 5. And 2 over 24, well, those are both divisible by 2, so 1 over 12. Okay, now I'm going to rewrite stuff. I only have 4 on top, and then my denominator is 5, and then x cubed, and then 12, and then x to the 6th. Okay, now I just did that because it's just easier if I try to simplify stuff down as quickly as possible before I start multiplying. That way I keep my numbers small, right? So I don't have to worry about or think about the really, really big numbers. What I can do here, 4 and 12 can reduce 1 over 3. All the x's are on the bottom, so they don't cancel. I've canceled everything else out on top except for a 1. And how many x's are there total? We add 3 plus 6 is 9. So this is my answer. So is this defined at 0? If I plug 0 into this, does it make sense? No, it doesn't, because I end up getting 1 over 0, which is undefined. Okay, so our answer to this question is no, it is not defined at 0. Okay, now the next part of this video, we're going to talk about dividing rational expressions. But before I do that, I want to talk about dividing fractions. Okay, the same thing that we have, I think you learned this in middle school. I'm not entirely sure. Okay, dividing fractions is the same thing as multiplying by the reciprocal of the second fraction. It's the whole keep, change, flip idea, right? KCF, if that's something that you guys learned. So I'm going to keep the first fraction the same. So the 1/2 is going to stay 1/2. Okay, I'm going to change the division sign to a multiplication symbol or a dot or an X. I would use dots just because you're going to have to deal with X in the problems. And I'm going to flip the second expression. So in this case, 1 over 5 turns into 5 over 1. And now I multiply like we've always done. Okay, so that is going to be the same premise of what we're going to do here. So for this problem, do the same thing. Keep, change, flip. We're going to keep the first radical expression the same. So I'm not going to change it at all. I'm going to change the division sign to a multiplication symbol, and I'm going to flip the other. So the numerator becomes the denominator, and the denominator becomes the numerator. Now we multiply. Okay, so see, any of those numbers, 2 over 7 doesn't reduce, 4 over 5 doesn't reduce, 2 over 5 doesn't reduce, and 4 over 7 doesn't reduce, so I can't change the numbers at all. But what about the letters? There are 4 P's here and 4 P's here. They cancel out. All right, so now I'm just going to multiply across. 2 times 4 is 8. 7 times 5 is 35. So this is kind of a special problem because P cancels out. All right, so, but just for the record, P still cannot equal 0. Okay, this is still not defined at 0. All right, because if I plug in like 0 for P at the very beginning, okay, I'm going to end up, when I flip stuff, this is going to end up being 4 over 0, and that's undefined. So at any point in the problem, are you dividing by 0? It's automatically undefined at that for the rest of the time. Okay, just because I don't have any variables at the end doesn't mean that it's still not, still not undefined. Okay, we're gonna do one more, and then I'm gonna let you go because we're a little over 9 minutes so far. Same thing, keep, change, flip. I'm not gonna do anything. Don't start reducing stuff until after you do the keep, change, flip, okay? then you can do all, I don't know why I wrote A, that's supposed to be a Y. I'm so sorry. That's a 3Y instead of a 3A. Don't know why. Okay, there we go. So I'm gonna rewrite this so it looks a little nicer for us. 3y over 4. Okay, now I'm gonna start canceling stuff out if I can. The only things that I can cancel out are this 12 and this 4, right? They're both divisible by 4, so that becomes 3 over 1. All right, the y's can't cancel because they're on the same level. They have to be on different levels in order to cancel. So now I'm going to multiply across, and I actually have 7 y's because there are 6 here and 1 in the second fraction, and 6 plus 1 is 7. And in my denominator, I just have 5 times 1, which is 5. Okay, now for this problem, let's talk about this for a second. Is this problem defined at y equals 0? Can y equal 0 for this problem? Well, if I plug in 0 at the very beginning, okay, and I do the whole keep, change, flip thing, I will end up getting like 0 over 5 times 0 over 4. And that's a 0 over 20, which that is okay. Okay, so what that means is, yes, this is defined at y is equal to 0. That means that y is equal to 0 could potentially be a solution here. I didn't ask for you to solve for it. I just asked us basically to multiply, divide, and reduce. Okay, I just need to know, is it defined at 0? Could 0 be a possible answer?